Hi, my name is Jamie Zalay, and I'm a grad student working at University of Colorado under Mihai. And my poster title is Measuring the Lunar Dust Cloud, and it is at A27. What I've been working on at Colorado is the Lunar Dust Experiment, or LDEX, and this is a dust detector going to the moon in 2013. The reason we're sending it is because there have been a handful of observations, mostly during the Apollo era, that have led us to believe there's a distribution of dust above the lunar terminator from anywhere from tens of centimeters to tens of kilometers. However, the evidence for this is not quite conclusive. So while we've had this question on the table of whether or not this dust is actually above the terminator for tens of years, we're finally going to be able to answer it in about 2 years. So in 2013, LDEX is going to go to the moon aboard LADEE, and it's going to fly across the lunar terminator hundreds of times, giving us ample opportunity to determine whether or not this dust is actually there. So if you're interested in this and you'd like to talk about this exciting measurement, I'll be at A27, and the talk is Measuring the Lunar Dust Cloud, and my name is Jamie Zalay. Thanks.
Hello, my name is Evan Thomas. I work at the University of Colorado at the Colorado Center for Lunar Dust and Atmospheric Studies. And some of you may know, but a 3 megavolt lunar dust accelerator was recently built at our facility in Boulder. And the purpose of this accelerator is to investigate micrometeoroid impacts on the lunar surface by mimicking the lunar surface with solar wind and UV and other effects that we see on the moon. And it is also a user facility, so it is open to anyone who thinks that their experiment would benefit from being bombarded by particles from 1 to 100 kilometers per second. And what I am especially working on is the particle selection unit, which is important if you have, let's say, an impact foil experiment that needs particles from, let's say, 40 to 50 kilometers per second. And those particles happen to be very small in charge. And it's difficult to trigger off of those signals with analog circuitry. So I'm building a digital FPGA-based particle selection unit that uses a cross-correlation algorithm to determine the speed and charge of those particles. And my poster number is A28. The title is FPGA Signal Processing for Real-Time Dust Detection. And you should come by if you're interested in what I do, or if you think that your project could use a similar technique for low SNR signals. Thanks.
Hello, I'm Anthony Hsu, also at the University of Colorado at Boulder. I also work at the 3 megavolt dust accelerator. You've probably heard pretty much everything I was just about to say a couple of seconds ago. But I'll also add that at the Dust Accelerator facility is actually online now. We've actually participated in material studies with Douglas Curry's lunar retroreflector fused silica samples. We also have done a partial calibration of the LDEX instrument that you just heard from Jamie. You can hear about this and a couple of other experiments, as well as the capabilities of our accelerator at my poster that is at A26. The 3 megavolt dust accelerator at the Colorado Center for Lunar Dust and Atmospheric Studies. Thanks a lot.
Hi, I'm actually Paige Norton, not Adrienne Dove, but we decided it would be more correct if we switched that up since I'm with the Dust Accelerator group. On that note, I work with Tobin Munsat and Mihai Hariani at University of Colorado Boulder, where I just very recently finished my undergrad degree. I'm part of the Dust Accelerator group, which my wonderful colleagues just told you all about. So I'll just tell you a little bit about what I do. And that's, my work is doing simulations and instrument development for focusing and alignment for the beamline. Most notably, I guess, would be I'm developing a particle position detector, which will go into the beamline, and from there we can get data on the XY position of particles as they fly through the beamline, so we know exactly where in the beamline they are. And if you'd like to hear any more about my work, I have a couple other instruments that I've done, and then any more about the accelerator, in case you can't hear enough from Anthony and Evan. I'll be at my poster tonight, A23, and my name is Paige Norton. Thanks.
Hello, I am Adrienne Dove, not Paige Norton, and I also work at the University of Colorado with the Colorado Center for Lunar Dust and Atmospheric Studies. Mihai Harani is my advisor, and I also work with Scott Robertson in the physics department. I do not work at the accelerator, however. I work on studying photoelectron sheaves and how dust behaves in the photoelectron environment, which mimics the day side of the moon. But I'm actually going to talk to you right now about a side project I did last week out here at Ames at the Lunar Regolith test bed. The poster for this is A16. My poster for my other work is A17, so right next to each other, easy to find. So I brought a Faraday cup out here to the Lunar Regolith test bed, which is full of JSC 1A, and we're interested in looking at the charge on dust grains. So we put the Faraday cup, which dust grain drops inside, we detect the charge, and we can see, based on how far it is from a rover wheel, for instance, what the charge is on the grain, and we can do different measurements then to see how dust grains charge as they move around on different surfaces. We were first interested in this problem because on the Apollo 16 mission, they drove a rover around what they called the Lunar Grand Prix, and they kind of went joyriding on the lunar surface. But as a result, it kicked up a lot of dust and these characteristic rooster tails behind the rover. And if we had something on the surface of the moon, like a Faraday cup or an array of Faraday cups, we could have measured the charges on those dust grains to see why they were behaving the way they were. And so this is also an EPO activity, and it can be extended for classrooms. And if you'd like to hear more about this, come talk to me at my posters. Thanks.
Hello, my name is Marcus Paquette. I'm an undergraduate at the University of Colorado at Boulder. I work for the Colorado Center for Lunar Dust and Atmospheric Studies with Mihai Harani. My research deals with the dusty plasma environment on the lunar surface, as well as the effects that topography has on dust transport within the plasma. Apollo-era observations have suggested the possibility of electrostatically levitated dust above the lunar surface. These observations include lean measurements and surveyor images. To investigate this phenomena, both the plasma environment and dust interactions within the plasma were modeled. The plasma environment was modeled over a 6.5 meter crater with a three-dimensional particle and cell code. A full day of plasma conditions were achieved by varying the solar zenith angle by 15 degrees for each simulation. As for the dust interactions within the plasma, we introduced a large number of charged dust particles within the plasma and traced its trajectories and recorded where they landed. Using the full day of plasma conditions, we were able to look at any net transport throughout the lunar day. And what we found is throughout the lunar day, there's actually a net transport towards the center of the crater. Now, this process of electrostatically levitating dust could be the mechanism that causes levitating dust above the lunar surface, and also dust ponding that is seen on Eros 433. I actually do not have a poster or a talk, but if you are interested in this or have any comments, I'd be more than happy to talk with you. Thank you.
Hi, I'm Nate Skolnik, and I recently graduated from Thomas Jefferson High School for Science and Technology. And next year I'll be going to Georgia Tech with intent to study aerospace engineering. But in high school, I was a member of the automation and robotics laboratory, where I did the project, an autonomous rover for lunar and radio antenna deployment with Dr. Joe Lazio of JPL. This rover was intended to avoid obstacles that a rover may encounter on the moon, and then deploy the polymer Captain film that other students have talked about in the lightning rounds. To do this, I used VEX robotic components, an Arduino microcontroller, and then for the autonomous portion, the Arduino programming language, and then infrared sensing technology. Again, I'm Nate Skolnik, and my poster is A9, and if you want to talk to me and see the actual robot that I built this year, come talk to me. Thanks.
Hello, my name is Hannah Adams, and I recently graduated from Kickapoo High School in Springfield, Missouri, and I was able to be a part of our school's lunar team, along with Allie Fest, Richie Hearn, and Cody Carroll, and also our sponsor, Mr. Rick Snyder. And our research was differentiating primary from secondary craters on the lunar surface, and we mainly focused in the southeastern Mare Imbrium region. And at first, we just used qualitative observations to try to preliminarily determine whether these craters were primary or secondary. And then the main focus of our research was actually measuring the boulders within a 16